in question 1, we've got this line EB. Now this line passes through the center and it makes a right angle with the chord AD. So if that's the case, we can say that this length here is equal to this length here. So we could say, therefore, 3x minus 1 is equal to x plus 5. So now we just have an equation to solve. So 3x minus x will be equal to 1 plus 5. So 3x minus x is 2x. 1 plus 5 is 6. Therefore, x will be equal to 3. And you can put that number back and double check. So if x is 3, 3 3s are 9, minus 1, this will be 8. And then 5 plus 3 is also equal to 8. So this looks correct then. So in this case, x equals 3. So in question 2 here, we want to find the radius of the circle O. So let's make a radius using the information we have. So we'll draw the line down here, call that R. Now this line passes through the center, O, at a right angle, which means that this line, which is 8 centimeters long, the line segment, which is 8 centimeters long, will cut your chord into 2 equal parts, okay? So then this length here has to be 15 cm. So let's call this, well, this is 8, and we want to find R. So let's apply Pythagoras' theorem to find R. So we'll have 8 squared plus 15 squared, which is R squared. And if you calculate that, you're going to get R being 17 cm. So I won't show all the working there. You basically add those two numbers and take the square root, right? So we'll get 17 for the answer for the radius. So in question 3, we want to find the length of the radius to the nearest centimeter. Okay, so this actually can be rounded off to the nearest centimeter. If AC is 10 and BD is 3. So AC is 10. That's this length here. Now, because DO is intersecting AC at a right angle and passes through the center, therefore AB and BC are equal length. So that means that AB here could be written as 5, and also BC could be written as 5. And BD is 3 here. And we want to find the radius here, R. So what I recommend to do is that we see that DO is also a radius, and part of that radius is 3. This remaining bit can be written as R minus 3, like that. And then we apply Pythagoras to this triangle here. Okay, and then we'll do Pythagoras. So we'll have 5 squared plus R minus 3 squared equals R squared. So now we need to expand this part here. So we'll have 25 plus R squared minus 2AB minus 6R plus 9. So just review your binomial expansion here. You should get this number. And then that will equal to R squared on that side. Now, the good thing here is that the R squared will cancel. Okay. And then we'll isolate the minus 6R. We'll move that to the other side. So we'll have 6R equals 25 plus 9. So just move your minus 6R out the way. So you'll have 6R is going to be 34. So R will be 34 on 6, which is 5 2/3 cm, if you want to be exact. But to the nearest centimeter, we could round that up to 6 centimeters. if we follow the actual question. Right, so question 4 states that AM is 7 centimeters. So that's shown in the diagram here. And the radius is 16. So that's OB or OA. We want to find the area of the triangle OAB. So that's this complete area of the whole triangle. So we see that as we have a line coming down through O, through the center of the circle, down to M at a right angle, chord is being bisected. So you could write 7 cm on this side as well. So the chord AB is 14 centimeters. So to get the area, we're going to need its height. So we'll write H there, and we'll apply Pythagoras to this triangle here. You can use that one, but it's the same answer. So we'll have H squared plus 7 squared equals 16 squared. So we'll have H squared is 16 squared minus 7 squared. And then if I want to find H, I'll take the square root of this number, 16 squared minus 7 squared. And putting that into your calculator, you'll get 3 root 23. I like to leave it in the third form, this exact form. I won't make a decimal just yet. So I'll leave it like this, and I'll do my final answer as a decimal. So that's the height of the triangle. So the area is half times the base times the height of the triangle. So the area will be a half times the base, which is this 14. This is AB. So times 14 times the height, which is 3 root 23. And in your calculator, that will give you 21 root 23, which is 100.71 cm squared. So you can leave it in exact form like this, or you can write it in a decimal form to 2 decimal places. So 100.71 square centimeters is the area. So for question 5, we've got P being the midpoint of the chord AB. So this is the middle of chord AB, and that's reflected by these 2 dash marks here. And AB and CD is perpendicular to AB. So we know that this is a right angle because it tells us that here. And we have a right angle. Now, if this is the case, this CD will pass through the center, which is about here. Call that O. And let's make a radius line because we don't have any triangles at the moment. So let's make a triangle down to there. And we have AB, which is 40. So if AB is 40, then half of 40 is 20. So we could write 20 on both of them. And PD is 6. PD is 6 here. And we want to find the radius of the circle. So we'll call that R. So let's label the radius R, which is the same as OA. But also OD is R as well, isn't it? OD is a radius. So part of that OD is 6. So the remaining part must be R minus 6 here. So these are the 3 numbers you need, R minus 6, and 20. And we'll do our Pythagoras on this section here. So we have 20 squared plus R minus 6 squared equals R squared. And then we need to simplify this and find R. So we'll have 400 plus R squared minus 12R plus 36 equals R squared. So if you bring the R squared over, you'll get negative R squared. So the R squareds will cancel like that. So we can just delete them. And then we'll have 12R, so let's bring the minus 12R over, and then we'll have 436 on this side. Okay, so R will be 109 on 3, if you simplify a bit, and you'll get 36 1/3 for the radius, cm, if you want to keep it in the exact form, or 36.33. So 36 1/3, or 36.3 recurring cm. So that would be the radius of that circle.